Good evening, learners. We continue looking at the pressure. Different questions taken from the topic called pressure. Right, so welcome to this number 8, question number 8. We are told that a block measuring 20 centimeters by 10 centimeters by 4 centimeters rests on a flat surface. The block has a weight of 6 newtons. Determine the minimum pressure it exerts on the surface. Right. So let's visualize the block. So the block is usually something like this. A block, something like this. So that's the block. Sorry. Roughly, that's what we have. So its length is 20 centimeters. It has a width of 10 centimeters and a thickness of 4 centimeters. Right, so to find the minimum pressure, it means we should find the maximum area. And then we divide that maximum area into the given force. Right? So the maximum area is obtained by simply multiplying length by width. Okay, remember pressure for a constant weight or force, pressure is force over area. In this case, weight over area. So for the pressure to be very small, it means the area should be large. Okay, so where do you find the area from? The large area is simply the length multiplied by width. If you take this area here, this area is very small. So if it lies on this area, it means you have greatest pressure. Okay, so that's what we needed to do. Just take the given length multiplied by the given length. The given length multiplied by the given width. Okay, so pressure using the formula, pressure is equal to force over area. Minimum pressure is force, which is the weight of the block, divided by maximum area. So how do you find the maximum area? Just take 20 multiplied by 10. Multiply 20 by 10. So multiplying 20 by 10 centimeters, then divide by 10,000. Why are we dividing by 10,000? We are dividing by 10,000 to change the area in square centimeters to area in square meters. Alright, so we are told that the force or the weight is 6 newtons. So we divide 6 newtons by 0.02 square meters. It should give you 300 newtons per square meter. Remember this way of writing. This one, Newton per square meter, is just the same as Newton per meter, but you raise this to Newton to the power minus 2. It's the same. If you don't prefer to use the slash here, just raise the m to the power minus 2. And this is the same as 300 pascals. 300 pascals. Okay. Now, next, we are asked to calculate or to determine the density of the block, okay, in kilograms per cubic meter. Right? So remember that density is mass divided by volume. So using density equals to mass divided by volume, you can calculate density. So in order to find the density, we are not given mass, we are given weight, which is in newtons. So in order to find mass, mass is simply equal to weight divided by acceleration due to gravity, g. So our weight is 6 newtons, acceleration due to gravity is 10. So this will give us 0.6 kgs. Okay? Then you go ahead to calculate volume. So volume, remember, volume is length times width times height. Okay? Length times width times height. So our length is 0.2 meters, which you change from 20 centimeters, just divide by 100. Divide each of these by 100 to change to meters. Okay? Then you have 0.2 multiplied by 0.1 multiplied by 0.1 multiplied by 0.04. You get 0.04 from dividing 4 by 100. So if you do your calculation properly, multiply this out, you should be able to get a volume of 0.008. Then you go ahead to use your formula for density. So density equals to mass. Our mass is 0.6 kgs and our volume is 0.0008. So if you do your calculation properly, you should be able to get 750 kilograms per cubic meter. Please convince yourself that you can do this, and be confident. Be confident, right? Be confident. Yeah. Okay. So that is that part. Then we move on to number 9. A block of, we are told that a block of mass 60 kgs measures 6.6 by 5 by 4. Calculate the maximum pressure that it can exert. So maximum pressure is found by dividing force by minimum area. All right. Once again, if you sketch this this body, this block, you must have something like this. You must have something like this. Yeah. So this is 6 centimeters, 5 centimeters, and 4 centimeters. Yeah. So the minimum area will be obtained if the box is lying on this side. This is the smallest area. So what is this smallest area? It is going to be 5 multiplied by 4, which is 20 square centimeters. But you divide by 10,000, like shown here. Divide by 10,000 to change it to square meters. In order to change the area from square centimeters to square meters, you simply divide by 10,000. Don't forget that. Okay? All right, so we have the area there. Now we need to find force. Force is just weight. Remember, weight is equal to mass times acceleration due to gravity, mg. So in this case, you simply take the given mass, which is 60 kgs. Then you multiply this by 10 newtons per kg or per kilogram. So the kgs will disappear, and then you have a weight of 600 newtons. Then you continue substituting. You substitute in your formula. Pressure is equal to force over area. So our force is 600 newtons, and our area is 0.002. So if you do your calculation correctly, you should be able to get 300,000 newtons per square meter. This, remember, again, is the same as 300,000 pascals. Okay, you can write the unit like that. Okay, I hope so far so good. We are together there. Sorry if I'm very quick. You bear with me. Don't hesitate to say so or to ask where I've left you behind so that we move on together. Okay, great. Similarly, you will do the same thing if you are to calculate, you are asked to calculate minimum pressure. So minimum pressure is obtained when you divide the force by the maximum area. Minimum pressure is simply minimum pressure is simply force divided by maximum area. So in this case, we shall look at the maximum area. How do you find the maximum area? Maximum area is going to be found by multiplying 6 by 5. So you multiply 6 by 5, multiply 6 centimeters by 5 centimeters, but don't forget to divide by 10,000 to change your area to square meters. Right, so then you go ahead to find pressure. So pressure is force divided by area. Force divided by area. So our force is 600 newtons. The area is 0.03003 square meters, which when you divide properly, you should be able to get 200,000 newtons per square meter. Please take note that newtons per square meter written like this is just the same as newtons per square meter. It's a different way of writing the same thing. But where you are using minus power, don't put you don't put what slash there. Just write NM raised to the power minus 2. All right, so I hope so far so good. In case you have questions, don't hesitate to contact us so that we clarify what you might miss. All right, so that's basically what we are saying. Okay, number 10, a man of mass 80 kgs, a man of mass 80 kgs. A man of mass 80 kgs exerts a pressure of 200,000 pascals on the ground while standing on both feet. Calculate the area of each feet. All right. Okay. So from pressure, you know pressure is force divided by area. Okay. Force divided by area. But we are asked to calculate area. So you make area, the subject area will be equal to force divided by pressure. Okay. But what is force? Remember, force is equal to weight. So you take the weight of the person, of the man, divided by the pressure that he is exerting. So force is, the weight is, we are given kgs here. So you change this by 2 newtons by multiplying by 10, which is 800. So we have 800 newtons divided by pressure, which is, so it's 800 divided by 200,000. So you divide this by 200,000 pascals. Okay, but area is supposed to be in square meters. So if you go ahead, calculate this, let's see, 800, let's get our calculator. We have 800 divided by 200,000. 800 divided by 200,000. You should be able to get 0.002. 0.004, this one here. But remember to leave your answer in square meters, because you're talking about area. You're talking about area. So area needs to be in square meters. Once again, that's the area. So please verify with your calculator to find the same value. My name once again is Mr. Pochilola. I'm glad that you're there. We are working together. Oh, but don't forget, you need to divide it, because a person has 2 feet. So you can find the area of each foot. Area of each foot, which is this one here. You simply take 0.004 divided by 2, which is 0.002 square meters. Don't forget that. The 0.004 we found was for area of 2 feet, but we are asked for 1 foot, so we needed to be courteous about that. All right. How much pressure would he exert if he stands on 1 foot? Okay, so 1 foot, you said area of 1 foot, area of 1 foot. We found it is 0.002. Therefore, pressure, using pressure equals to force divided by area, we shall have the pressure will still be the same, 800 newtons. The force will be the same, 800 newtons. Then you divide this by the area of 1 foot. This must give you 400. So the pressure is almost doubled. We have reduced the area by half. The pressure is going to be doubled by 2, to be doubled. Okay, so it's going to be 0.000 400,000 is 400,000. Don't forget newtons per square meters. Thank you. This is what you are supposed to have done in an exam. If you were asked to do this kind of problem, that's what you actually do. All right, question number 11. You're told a woman wearing shoes with sharp pointed heels exerts more pressure than an elephant. This again is to do with the effect of area on pressure. If you compare the foot of a woman wearing sharp pointed shoe. Let's say this is the shoe. We have a woman wearing it. We are talking about this sharp pointed foot or shoe, and think about the foot of an elephant. Foot of an elephant, something like that. All right? Okay, so you compare this area here in contact with the ground, and this area here, which is also in contact with the ground. Okay, so using the fact that pressure is equal to force divided by area, you do appreciate that, of course, here the weights are also important. We are not assuming that the woman and the elephant have the same weight. No, that's not the assumption. But the assumption here, we are looking at the variations in area. This is small area, that's a big area. Okay, so small area results into high pressure. Big area results into smaller pressure. So the question is, a woman wearing shoes with sharp pointed heels exerts more pressure. This exerts more pressure than the elephant. Why? Okay, so the explanation has to do with area. So shoes with sharp pointed heels have small area. you'll say that 1 mark of contact with the ground, which results into large pressure. Hues with pointed hues have, pointed means very sharp. Here, over here, we have a sharp hue there. Okay, so hues with sharp pointed hues have small area. By saying this, already you have 1 mark with the ground, which results into large pressure, another mark. Okay? Unlike the broad feet of an elephant, so the elephant has the broad feet, this broad feet, which results into low pressure being exerted on the ground. Okay? So these concepts are very, very important. As a matter of fact, I would really appreciate if this question was 4 marks, so that you have a mark for saying small area for sharp-pointed hues, large pressure for the same, and broad feet, large area for the elephant, and low pressure for the same. Okay, so that's basically what you would have, what you would have said if it were you in an exam. Okay, so I would like to leave you here with the last question, question part B, for you to, that's for you to work on. They are saying if the weight of a woman is 600 newtons and her hue have an area of 1.0 square centimeters each, and the elephant has a weight of 30,500, and each feet has the area of 730. Calculate by how much more the woman exerts pressure on the ground. Okay, just go through the solution here and appreciate the working out what needed to be done, or what you'd do if it were you doing the same in an exam. For now, I would like to leave you. Please go through the solution and just appreciate the work that has been laid out here. Okay, so once again, my name is Mr. Poechilola, wishing to meet you again in the next session, where we continue with the pressure. So we'll meet again. We'll continue with this, the next part, until we finish the topic called